7.4 notes. We're going to continue with logarithms. We're going to learn properties of logarithms. So what we can do with our logarithmic functions. So for any positive numbers m, n, and b, so here it just gives us variables as examples, where b is not 1, the following properties apply. So we have the product property. So when we multiply two things together, so it could either be variables or it could be numbers, we expand our logarithm by breaking it up and adding them. So multiplication goes with adding. And then notice here, when we expand it, every time we break it up, each variable or each number gets its own log. For our quotient property, this is when we divide. So when we're dividing two things, dividing goes with subtraction. So when we break it up, we subtract. So dividing goes with subtraction. And then our exponent property, or power property, when we have an exponent, when we expand it, we move it to the front of the log. So notice here it's being multiplied in front of the log. So we're going to be expanding and condensing logs. So when we expand, we make bigger. And each term gets its own log. When we condense, we make it smaller. And our final answer only has one log. We'll do some examples and you'll see what I mean by that. So it's super important to remember multiplication goes with addition and division goes with subtraction. So when we expand it, we add a multiplication or subtraction sign, but we could also condense it and go the other way too. All right, example 1. What is each expression written as a single logarithm? So we're writing just as one log, so we're going to be condensing it down to one log. Here, we're subtracting. So what goes with subtraction? Division. So we keep our log and whatever the base is the same. So we're going to do log base 4, and it's always the first number divided by the second one. So this will be 32 divided by 2. So when we condense it, we just have one log. We get rid of the other one. And then we can simplify this a little bit more because I can simplify 32 divided by 2. What is 32 divided by 2? 16. So my answer is log base 4 of 16. All right, let's look at B. So here I have numbers in front of my logs, so that means I use the power property. So these become exponents. So the numbers in front become exponents. So I would put it on top of the variable. So this now becomes log base 2 of x to the 6th power plus log base 2 of y, and what's my exponent there? The 5th power. Did I condense it down to a single logarithm yet? No, I still have 2. So what goes with addition? multiplication. So my log and its base stays the same, log base 2. And then what am I going to multiply? The x to the 6th power and y to the 5th power. So it'll be x to the 6th power times y to the 5th power. And since it's variables, we don't multiply it, we just leave it there. That's it. All right, example 2, we're expanding it. So it gives us just one log, and we have to expand it however many times we need. So what do I have that's going on between the 4 and the x? What's happening between 4 and x? I'm multiplying these two numbers. So what happens to expand? What goes with multiplication? Addition. So I'm going to add log of 4. Here there's no base, so we just write log. So log of 4 plus log of x. Every time you expand it, you add a new log to it. And then what's happening with the y? Division. And what goes with division? Subtraction. So what do you think would come next? So minus log y. Every time you break it up, each term gets its own log. All right, let's look at b. So here our base is log, we have log base 9. So that's going to come with us every time we expand it. So what's happening between the x to the 4th power and the 729? Between the term on top and the one on the bottom. Division. What goes with division? Subtraction. So I start with log base 9 of x to the 4th power. What comes next? Minus what? Log base 9 of 729. So every time you break it up, it needs its own log. And then I have an exponent here. So what do I do with that exponent? I move it to the front. So this will be 4 log base 9 of x minus log base 9 of 729. And that's our answer. All right, so the next thing we're going to learn is a common log. So a logarithm with base 10 is called a common logarithm. If no base is written for a logarithm, the base is assumed to be 10. For example, log of 5 is the same thing as log base 10 of 5. So our calculators automatically assume that everything is a common log. Most calculators only can do common logarithms. You can only put log 5 in your calculator because it automatically just assumes that it's a base 10. Some people's calculators, you're able to change the base. Some you're not. So calculators just think that every log is a common log. So we have a formula to put our logs in our calculator by making them common logs. So this is called the change of base formula. For any positive numbers m, b, and c, when b is not 1 and c is not 1, we can change the base of our log. So it would be log of m divided by log of b. So in our calculator, I'll do an example down here at the bottom. Let's say I had log base 4 of 6. The bigger number goes on top, so that would be log of 6 on top. And the base goes on the bottom, so think base on the bottom. So then log base 4 would go on the bottom. And then we can put this in our calculator. We would just say log of 6 divided by log of 4. And then equals. And that would give us an answer. So for these questions, you guys need your calculator, if you still have them. So make sure for the test, you have your calculator. If you're using the iPhone calculator, you have to put it in parentheses. So you'd have to do 6 log in parentheses and then 4 log in parentheses. It's easier on a calculator. The iPhone gets kind of confused. Or you could do it 2 separate times. So do log of 6 and then divide it by log of 4. So if you guys do it right in the calculator, you should get 1.2924. When we do the change of base here, it automatically assumes that it's log base 10. So doing the change of base formula lets us put it in the calculator. So we can round to 3 or 4 decimal places. So here, when doing the change of base, which number is going to go on the top? 27, because remember, the base goes on the bottom. So we're going to take the log of 27 and divide it by the log of 81. So in the phone calculator, you have to do it separate. It's a lot easier in a calculator. So for tomorrow, for your homework, make sure you have a calculator so you know how to use your calculator. So if you do it in the phone and you do it separate, you get 1.43136 on top. And then when I take the log of 81, I get 1.90848 on the bottom. And then I have to divide these two numbers. So that should give us 0.7499. Yeah, you could round, but or just keep like 4 decimal places. So if you did it all in the calculator together, it probably gave you 0.75. It just rounded it for you. So if you do it in 2 separate steps, you'll get a decimal, but you can just round it. All right, let's do number, or B, I guess. Which number is going to go on the top? So log of 36 on the top and log of 5 on the bottom. So some calculators, you have to do it separate. So we would do log of 36. And that gives you 1.55630. We'll say 02. And then I would do log of 5 on the bottom. And get 0.69897. And then we divide these. So 1.556302 divided by the bottom. And you should get 2.22656. Anybody else get that? You can round.